Right. So friends, our topic of discussion for this short video today is differentiation between three terms which are very nearer in meaning in strength of materials. These three terms, namely, as you can see in the screen, are stress, strength, and pressure as defined in strength of materials. These terms are nothing new for any civil engineering or structural engineering student or any design engineer for that purpose. So we should have a basic clarity with regard to the differences in these three terms. So moving ahead with the first term, if you can see stress. Now what is stress? Stress has been defined in strength of materials or in mechanics as the resistance force acting per unit area of cross section of any material. Now when I am mentioning it as a resistance force, what do I mean basically? It relates to our knowledge of physics back in 12th standard with regard to the laws of motions, Newton's laws of motions. And here I am specifically referring to the third law of motion, which says every action has an equal and opposite reaction. So stress comes from the reaction that is generated out of any action. Basically, pressure is related to the action and stress is related to the reaction force acting due to that action. So stress is the reactive force acting per unit area of the material, and it is generally denoted by sigma, where sigma can be written as sigma equal to resisting force R upon cross section area A, or sigma is equal to R by A. So unit wise stress is represented in terms of Pascal, that is Newton per square meter, and the other units being kilopascal, or in which 1 kilopascal is 1000 Pascal, and megapascal 1 megapascal being 1000 kilopascal. Now one important unit in design engineering is 1 megapascal, which is also is equal to 1 Newton per square mm. So in design engineering we generally use the unit of 1 MPa or 1 Newton per square millimeter for stress. And unit wise, both stress and pressure are equivalent to each other. But as I mentioned earlier, the pressure is due to the applied force or the main force which is acting on any substance, and stress is on account of the reaction of that applied force or response of that force. So to understand this difference in a better way, we have a pictorial representation of a bar element having a cross-sectional area A. Now suppose this bar element is being pulled by a force P on both the ends. So we can say that a tensile force is acting on the bar on both the ends, represented by P. If we want to represent the pressure acting on that body due to this force P, it will be pressure is equal to P by A. Whereas now if we consider the FBD of the body with the bar and all the internal forces being represented, we will see that an internal force R is represented within the body, and the stress developed within the body due to the pressure P or the force P will be R by A, and the A being the area of cross section of the internal part, which is again same for both the cases. So the stress developed will be R by A and not P by A. This differentiation should be clear to all. Stress is R by A and pressure is P by A. So stress is on account of the reaction developed in response to the applied force, and pressure is on account of the applied force itself. Now moving on to the next term, which is the strength. Now what do we mean by strength basically? In mechanics, strength is generally represented in terms of stress only. That is, it is also has the unit of Newton per square mm. Now the strength of the material is basically the ultimate level of the stress developed in the body due to the force acting on that, and it has been defined as the resistance of the material to prevent the final ultimate state of failure in the body against any applied force. And since the level of resistance of the body depends on the nature of the molecules of the internal molecules of the material which is acted upon when the force is acting, so strength is basically a material property. And for your kind information, the strength is the basic parameter or the primary criteria of material design in any design engineering field, be it civil engineering or mechanical engineering or aeronautical engineering, strength is our basic primary criteria for material design. And when we talk about stress strength, the another thing that obviously comes into our mind is what is called as strain. Now, stress is actually basically the dependent quantity. That means it is not the main quantity or the basic quantity. What is the basic quantity or the fundamental quantity is the what is known as strain. Strain basically leads to the condition of stress in a body. So definition wise, strain may be defined as the measure of extent of deformation occurring in any material when a force is being acted upon that material. And it is defined as the mathematically as the ratio of the change of the dimension to the original or initial dimension of any substance. So if we understand the analogy, if applied force will be acting on any body, and this will lead to the state of deformation in that body, which is known as the strain with respect to the original state of the body, if we consider the ratio. And this will finally lead to a state of response, which is known as the stress occurring in that body or generated in that body. So strain is our fundamental quantity, but stress is the dependent quantity. Therefore, what I can say is that, just to add up here, if you draw a plot between stress and strain, and if you compare this to a standard graph of y and x, y being the independent quantity and x being the dependent quantity, so in terms of x, we place stress, and in place of y, we place strain, because strain is the independent one and stress is the dependent one. And generally, unit wise, strain is denoted by epsilon, whereas epsilon is equal to the change in dimension to the original dimension or the initial dimension. That is epsilon equal to delta x by x. And since it is a ratio, strain does not have any unit basically. And generally in laboratory or in field, strain is basically measured in terms of some devices which are like extensometer, that is strain gauges available, or dial gauge, like round dial gauge, which are generally used in the laboratory, or LVDTs, that is linear variable differential transducer, in which an electrical signal is being introduced, and this is converted in the form of any mechanical energy which calculates our strain. That ends our video here. Thank you for this.